Units and measurements. Summary. Physics is a quantitative science based on measurement of physical quantities. Certain physical quantities has been chosen as fundamental or base quantities such as length, mass, time, electric current, thermodynamic temperature, amount of substance and luminous intensity. Each base quantity is defined in terms of certain basic arbitrarily chosen but properly standardized reference standard called unit, such as meter, kilogram, second, ampere, Kelvin, mole, and candela. The units for the fundamental or base quantities are called as fundamental or base units. Other physical quantities derived from the base quantities can be expressed as a combination of the base units and are called derived units. A complete set of units, both fundamental and derived, is called a system of units. The International System of Units (SI), based on 7 base units, is at present internationally accepted unit system and is widely used throughout the world. The SI unit are used in all physical measurements for both the base quantities and the derived quantities obtained from them. Certain derived units are expressed by the means of SI unit with special names such as joule, Newton, watt, etc. The SI unit have well-defined and internationally accepted unit symbols such as M for meter, kg for kilogram, S for second, A for ampere, N for Newton, etc. Physical measurements are usually expressed for small and large quantities in scientific notation with powers of 10. Scientific notation and the prefix are used to simplify measurement notation and numerical computation, giving indication to the precision of the number. Certain general rules and guidelines must be followed for using notation for physical quantities and standard symbols for SI unit. Some other units and SI prefix for expressing properly the physical quantities and measurements. In computing any physical quantity, the units for derived quantities involved in a relationship are treated as though they were algebraically quantities till the desired units are obtained. Direct and indirect methods can be used for the measurement of physical quantities. In measured quantities, while expressing the result, the accuracy and precision of measuring instrument along with errors in measurement should be taken into account. In measured computed quantities, proper significant figures only should be retained. Rules for determining the number of significant figure, carrying out arithmetic operations with them, and rounding off the uncertain digit must be followed. The dimension of base quantities and combination of these dimensions describe the nature of physical quantities. Dimensional analysis can be used to check the dimensional consistency of equation, deducing relations among the physical quantities, etc. A dimensionally consistent equation need not to be actually be an exact correct equation, but a dimensionally wrong or inconsistent equation must be wrong.